Right now our database is completely empty, so I'm first going to solve that before we can actually use our API. I'm going to create a new folder inside of my Bookify API, which I will call extensions. And then I'm going to add a new class inside, which is going to contain my extension methods for the iApplication Builder interface. If we take a look at this class, it has only one method inside, which is called apply migrations, and I'm going to use this method for local development purposes to take the application builder and create a scope, use this scope to resolve my database context, and then apply any pending migrations to my database. How we are going to use this extension method is right after we configure Swagger, and I'm making sure that this is called only in my development environment. We're going to invoke the apply migrations method, and this is going to run our EF core migrations. And now all that's left to do is to create our first migration. First, we're going to need to add a NuGet package to our API project to be able to run migrations from our package manager console. I'm going to look for Entity Framework Core. I'm going to install the Microsoft Entity Framework Core Tools NuGet package, and I'm going to make sure that the version I'm installing matches the Entity Framework version that I have in my infrastructure project, which is the version 7.0.4. So let's go ahead and install this NuGet package. And now I should be able to create my migrations from the Package Manager console. Let's open up the Package Manager console, and I'm going to set my default project to infrastructure and my startup project to Bookify API. Then I'm going to add my command for creating a migration, and this is add migration, and then giving it a name. I'm going to call it create database. Let's execute this command and see what's going to happen. We're going to get an error that no suitable constructor was found for our entity type apartment. You're probably going to run into this if you are designing a rich domain model, and the solution is relatively simple. Let's head over to our apartment entity. All we're going to do is add a private parameterless constructor inside of the apartment class. We also need to do the same on our base entity class. I'm also going to create a parameterless constructor here, but I'm going to make it protected so that it can be callable from my entities. We have to do the same for the user, review, and booking entities. So I'm going to go ahead and add these constructors. So let's head over to the booking entity. I'm going to add the private constructor here, and let's also do that for our review. I'm going to navigate to the review entity and add a private parameterless constructor. Let's close all of these up and let's try to create our migration again. I'm going to run the same command of add migration, and I'm going to give it the name of create database. You can see our migration was successfully created, and let's examine what we have inside. First of all, we have the apartments table with all of the columns that we defined on our rich domain model. The address value object that we had in our domain model is now mapped as a set of columns in the database. The same applies for the two instances of the money value object. Because I'm using Postgres as my database and it has support for collections, the list of amenities that I have on my apartment entity is going to be mapped as an integer array because this is an enum and it can be mapped to an integer. Then we have the xmin column, which is used as our row version for optimistic concurrency. I'm going to skim through the other tables that we have. Here are the users with the appropriate columns. Then we have our bookings table. You can see that the value objects are configured correctly. You'll also see that the bookings table is having the proper primary key, but also the foreign keys configured. Then we have our reviews table, which also has a few foreign keys of its own. And lastly, all of the indexes that we defined. And this is the one that we defined ourselves, which is the index on the user email property. And you can see that the call to make this a unique index is translated into our migration correctly. Now, when we start our application, our migration is going to be applied on our database, and we should have all of the tables populated. Unfortunately, the tables are going to be empty. So I prepared a helper extension method, which I added in the seed data extensions class. And we have just one method inside, which is going to use the same approach with migrations to resolve the SQL connection factory. It's going to create a list of 100 fake apartments, and then it's going to insert them into the apartments table. We're going to need to install the bogus library for this to be able to execute. So I'm going to look for bogus, and I'm going to install it. And then to run our seed data method, I suggest that you do it just once right after applying migrations. So you call app.seedData. You would run this once to populate your database, and then you can comment it out or remove it so that you don't keep adding unnecessary data. I want to show you what the data looks like at the database. I'm using dbeaver as my database management studio, and I connected to my localhost Postgres instance exposed on the port 5432. If I open up the databases, you'll see that my Bookify database is there while my container is running in the background. And if I open up the public schema, which is the default schema in Postgres, you'll see that all of our tables are properly created in the database. This is triggered when we run our migrations at startup, and I also took the liberty to seed some initial data in the apartments table, and you'll see that we have a list of 100 apartments that we can use to try to make some bookings. One more thing that we can do in the presentation layer is solve cross-cutting concerns by introducing middleware. So I'm going to create a folder in the Bookify API project, which I will call middleware. I'm going to add a global exception handling middleware inside, and let's take a look at what we have here. So we are defining our middleware by convention, which means that we have one public method called invokeAsync. It accepts an HTTP context, and we are injecting the request delegate from the constructor. I'm also injecting an iLogger instance so that I can log my exceptions. Then I'm wrapping my execution of the request delegate in a try-catch statement, and in the catch block, we are examining the exception that we get to extract some exception details. Inside of this method, all I'm doing is writing a switch expression on the exception and checking if this is a validation exception, which is an exception that we defined in the application project, and we are throwing it in our validation behavior mediator pipeline. If we do end up catching this exception, then we have a validation failure, and we're going to return an appropriate response. We also want to capture any errors that were part of this validation exception and return them with the exception details. If it is not a validation exception, then we have an internal server error and there's nothing we can do. Back in our catch statement, what we are doing with the exception details is creating a new problem details instance. Then I'm expanding this problem details instance with an errors property in case of a validation exception. It's going to contain my collection of errors inside. I'm setting the appropriate status code, and I'm writing the problem details as a JSON response in my response body. How are we going to add this middleware? Well, I'm going to define another method on our application builder extensions class, which is going to call the useMiddleware method and add the exception handling middleware inside. And then we're going to call the useCustomExceptionHandler method from our program.cs file. You should place your custom exception handler as early on as the middleware pipeline as it makes sense. I'm going to place it right before the call to map controllers, and we're going to call the useCustomExceptionHandler method, which is going to configure our global exception handling middleware. Now let's try some of the endpoints that we have defined inside of our API. I prepared some requests inside of Postman, and here's a GET request for searching our apartments. I added an environment variable, which is pointing to our API, and then the route is API/apartments, and we have two query parameters for the start and end date. Let's send this request to our API and observe the response that we get back. We get back a list of apartments that are available for the specified start and end date. You can see that all of the details in the apartment response are properly populated. Let's take the apartment ID of this apartment here and try to create a booking. I'm going to navigate to the bookings folder and open up the reserve booking post request. I define the body of the request as a JSON object, and I'm going to use the apartment ID that I know exists in the database because we got it back from the search apartments response. And I'm also going to use the same value for the user identifier because I know that this user doesn't exist. So let's send this request to our API and see what we get back. In this case, we are going to get a 400 bad request response saying that the user with the specified identifier was not found, and this is as expected. Now let's try to trigger our validation pipeline. I'm going to set the start date to be larger than the end date, and I'm going to send the same request again. This time we also get a 400 bad request response, only it contains a problem details response specifying that the start date has to be less than the value of the end date. This is caused by our validation behavior in the application layer, which is going to throw a validation exception, which is then handled by our global exception handling middleware, which takes the exception and returns a problem details response to the API consumer. With this short demonstration, we wrap up the presentation layer and we have a completely functioning application using clean architecture. In this chapter, we implemented the presentation layer of the clean architecture by using a web API built with .NET. I showed you how to introduce controllers and connect them with your application layer to send commands and queries. We also discussed how to solve cross-cutting concerns with an exception handling middleware as the example, and I showed you how to set up Docker Compose so that you can run the application using Docker. With the conclusion of this chapter, we have a completely functioning system that is built using clean architecture, and in the following chapters we are going to be dealing with some of the advanced concerns of the clean architecture.